Hello friends, today we are going to solve previous year's questions from Physics Class 11 Chapter 3 Motion in a Straight Line. Question 1. If a ball is thrown vertically upwards with a speed u, the distance covered during the last t seconds of its ascent is. Let h be the total height and capital T be the total time of ascent. So the total distance is given by ut minus half gt square in question 1, and let the distance covered by the ball in t minus t seconds, where small t is the distance covered in its last second and small h is the distance covered in last second, and x with the distance covered in capital T minus t second. So therefore x is given by u into t minus half g into t minus t whole square. Distance covered by the ball in last t second is given by h is equal to the total distance capital H minus x. So if you substitute the values from here and solve, we get h is equal to ut plus half gt square minus g into capital T into small t. We put capital T is equal to u by g, since v is equal to u minus gt, where final velocity is 0. So therefore we get capital T is equal to u by g. So therefore we get h is equal to half gt square. So question 1 is option B. Question 2. A man throws balls with same speed vertically upwards, one after another at an interval of 2 seconds. What should be the speed of the throw so that more than 2 balls are in the sky at any time? When the ball is thrown upwards, the final velocity becomes 0. So therefore initial velocity is gt. When there are a minimum of 2 balls in the sky with time interval of 2 seconds between them, so we get u is equal to g into 2. 9.8 into 2 is equal to 19.6 meter per second. When he throws a ball with minimum speed of 19.6 meter per second and a time interval of 2 seconds, the 2 balls can be in the air simultaneously. So therefore for more than 2 balls, the speed should be more than 19.6 meter per second. Question 2 is option A, more than 19.6 meter per second. Question 3. A ball is thrown vertically upwards. It has a speed of 10 meter per second. When it has reached 1/2 of its maximum height, how high does the ball rise? Taking g is equal to 10 meter per second square. So from the third equation of motion, we have v square is equal to u square plus 2ah, where acceleration is minus g. So we get v square is equal to u square minus 2gh. After reaching maximum height, velocity becomes 0. So we should break this whole distance divide in 2. We get half distance f by 2. So at the first half, the velocity is 10 meter per second. So for the second half, we get initial velocity as 10 meter per second. So we have h is equal to here. From this equation, we calculate h as 100 by 2. By substituting the values, we get 10 meter. So question 3 is option A. Question 4. 2 boys are standing at the ends A and B of a ground where AB is equal to A. The boy at B starts running in a direction perpendicular to AB with velocity v1. The boy at A starts running simultaneously with velocity v and catches the other in a time t, where t is. So the question is, 2 boys are standing at ends A and B. So if A and B are the ends of a ground and the distance between A and B is A, small a, the boy at B starts running perpendicular to the direction of AB with velocity v1. The boy at A starts running simultaneously with velocity v to catch the other boy in time t. So the time is t for both paths. So it makes up a right angle triangle. According to Pythagoras theorem, we have AC square is equal to BC square plus AB square. BC is V1t and AC is VT and AB is A. So from this we calculate t square as A square by V2 minus V square minus V1 square. So t is equal to whole root of A square divided by V square minus V1 square. Fourth is option A. So option D. Question 5. The displacement x of a particle varies with time t as x is equal to a into e power minus alpha t plus b into e power beta t, where a, b, alpha and beta are positive constants. The velocity of the particle will. So here x is equal to, the displacement is given as ae power minus alpha t plus be power beta t. Differentiation of x gives velocity. So if we differentiate it, we get v is equal to minus a alpha into e power minus alpha t plus b into beta into e power beta t, because differentiation of x with respect to t is equal to n into x power n minus 1. If we apply, we get this. For the certain value of t, velocity increases, so therefore the value of term minus a alpha e power minus alpha t increases, and of term b into beta power minus beta also increases with time. So therefore velocity keeps on increasing with time. Therefore it is option D. Question 6. A particle moves along a straight line OX at a time t in seconds. The distance x in meters of the particle from 0 is given by x is equal to 40 plus 12t minus t cube. How long would the particle travel before coming to rest? Again, they have given the equation for displacement. If we differentiate x with respect to t, we get v is equal to dx by dt is equal to differentiation of 40 is 0, a constant, differentiation of 12t is 12, and differentiation of t cube is equal to 3t square. When the particle comes to rest, we know that final velocity v is equal to 0. If we substitute this here, we get 12 minus 3t square is equal to 0. From there, t is equal to 2 seconds. The distance traveled before coming to rest is, so here integration of dx by dt with respect to time is equal to integration of v. Therefore we have integration of dx from 0 to x is equal to integration of v from 0 to 2 at time 0 to 2. So therefore we get x is equal to, if we substitute v here, then integration of 12 is with respect to t is 12t, and integration of 3t square with respect to t is 3t cube by 3 from 0 to 2 seconds. So if we substitute here the value of t, we get 12 into 2 minus 8 is equal to, the displacement is equal to 16 meter. So therefore question 6, option A. Question 7. Two bodies A and B of masses 1 kg and 3 kg respectively are dropped from heights 16 meter and 25 meter respectively. The ratio of the time taken by them to reach the ground is, we have two bodies A of 1 kg and B of 3 kg dropped from 16 meter and 25 meter respectively. Both are dropped from rest, so therefore initial velocity of A and initial velocity of B is 0. So therefore we have some equations of motion. Distance of A is equal to ut plus half gt square, and for B is equal to ut plus half gt square at time tv. So we have to calculate the time. This whole term is 0 because initial velocity is 0. So therefore from here ta is equal to root of 2sa divided by g. Also here tb is equal to root of 2sb divided by g. If we divide ta by tb, we get 2 into 16 by g divided by 2 into 25 by g. We substitute the distance here. Therefore we get root of 16 by 25, which is equal to 4 by 5. So the ratio of time is option A, 4 by 5. Question 8. The position x of a particle with respect to time t along the x-axis is given by x is equal to 9t square minus t cube, where x is in meters and t is in seconds. What will be the position of this particle when it achieves maximum speed along the positive x direction? Again we have the equation 9t of displacement is equal to 9t square minus t cube. Differentiate with respect to time, we get v is equal to 18t minus 3t square. Speed is maximum and differentiation of velocity is 0. dv by dt is equal to 0. dv by dt is equal to acceleration, and we differentiate this equation, we get 18 minus 6t is equal to 0. From there t is equal to 3. Substitute 3 in the value in the equation 1 where we have displacement. Therefore we get displacement as 54 meter. Option A. Question 9. A car moves from x to y with a uniform speed vu and returns to y with a uniform speed vd. The average speed for this rounded trip is... This is an easy question. We know average speed is equal to total distance traveled by total time taken. Total distance is s1 plus s2 and total time is t1 plus t2. Since the distances are equal, we get 2s divided by the distance. The time taken for the first distance is s divided by vu, and for second distance is s divided by vd. So therefore we get 2 vu vd divided by vu plus vd. Ninth one is option D. Question 10. A particle moving along x-axis has acceleration f at time t given by f is equal to f0 into 1 minus t divided by capital T, where f0 and capital T are constants. The particle at t is equal to 0 has 0 velocity. In the time interval between t is equal to 0 and the instant when f is equal to 0, the particle's velocity vx is as given in the problem. At time t is equal to 0, velocity also is equal to 0. When f is equal to 0, acceleration f is equal to f0 into 1 minus t by t. F is 0, so therefore f0 into 1 minus t by t is equal to 0. From there we get t is equal to, small t is equal to capital T. Also acceleration is equal to dv by dt. From time interval t is equal to 0 to t is equal to capital T, dv by dt, acceleration for this time interval is given by integration of dv with respect to t is equal to integration of acceleration f from time t is equal to 0 to t is equal to capital T. So if you substitute f is equal to f0 into 1 minus t by t and differentiate and integrate it, we get integration of dv with respect from 0 to vx is vx, and integration of f0 into 1 minus t by t gives us f0 into t minus t square by 2t from 0 to capital T. If we substitute the value of t, we get f0 t minus f0 t square divided by 2t. So therefore vx is equal to half f0 into t. Question 10, option C. 11. The distance traveled by particles starting from rest and moving with an acceleration of 4 by 3 meter per second square in the third second is... Distance traveled in third second is given by distance traveled, total distance traveled in 3 seconds minus total distance traveled in 2 seconds. Since the initial velocity u is 0, distance traveled in third second is equal to distance traveled in total 3 seconds is given by half into a into times 3 square minus half into distance traveled in 2 seconds a into 2 square. So you get half into 4 by 3 into 9, 3 square 9 minus 2 square 4, we get 5. So therefore the distance traveled in third second is 10 by 3 meter. 11, option A. 12. A particle moves in a straight line with a constant acceleration. It changes its velocity from 10 meter per second to 20 meter per second while passing through a distance 135 meter in t second. The value of t is... Since we have the value of final velocity, initial velocity and distance displacement, we can find out a is as v square minus u square divided by 2s. We get a is equal to 150 by 135, and we use a in the first equation of motion, v is equal to u plus at, from where we can find the value of t as v minus u by a. So 20 minus 10 is equal to a into t, 150 by 135 into t. Therefore t is equal to 9 seconds. 12, option B. 13. A particle shows distance time curve as given in the figure. The maximum instantaneous velocity of the particle is around the point. So the maximum instantaneous velocity is given where the slope is maximum. From all these points the slope is maximum at C. So therefore 13 is option D. 14. A bus is moving with a speed of 10 meter per second on a straight road. A scooter wishes to overtake the bus in 100 seconds If the bus is at a distance of 1 kilometer from the scooterist, with what speed should the scooterist chase the bus? Let Vs be the speed of the scooterist. Distance between scooterist and bus is 1000 meter. Speed of bus is 10 meter per second. Time to overtake is 100 seconds. Relative speed of scooterist with respect to bus is equal to Vs minus 10. We know that V is equal to displacement by time. Here V is Vs minus 10 is equal to displacement is 1000 and time is 100 seconds. So therefore Vs is equal to 20 meter per second. 14. Option D. 15. A particle starts its motion from rest under the action of a constant force if the distance covered in first 10 seconds is s1 and that covered in first 20 seconds is s2. Then since the initial velocity is 0 and we take the ratio of s1 and s2, we get half a into first 10 seconds t square divided by half a into second s2 to 20. We get 100 by 400. So therefore s2 is equal to 4s1. Option B. 16. A ball is dropped from a high-rise platform at t is equal to 0 starting from rest. After 6 seconds another ball is thrown downwards from the same platform with a speed v. The two balls meet at t is equal to 18 seconds. What is the value of v? Let the two balls meet after t seconds at a distance h from the platform. So for the first ball, initial velocity is 0, total time taken is equal to 18 seconds and g is 10 meter per second. Using the s is equal to ut plus half gt square, we have h is equal to half g into 18 square, equation 1. For the second ball, u is equal to v and t is equal to 18 minus 6 seconds because the balls are thrown at an interval of 6 seconds and the total time taken by the first ball is 18. So therefore time taken by the second ball is 12 seconds. We substitute the values here, we get h is equal to vt plus half g into 12 square. From equation 1 and 2, that displacement is equal in both the cases. So we get half g into 18 square is equal to vt plus half g into 12 square. If we solve this, we get v is equal to 75 meter per second. So 16, option A. 17. A particle moves a distance x in time t according to equation x is equal to t plus 5 whole power minus 1. The acceleration of the particle is proportional to. In the options we have velocity and distance. So the distance is given by t plus 5 whole power minus 1. Velocity is differentiation of dx x dx by dt is equal to minus of t plus 5 whole power minus 2. Question 2. Acceleration is given by dv by dt. We get plus 2 into t plus 5 whole power minus 3. From equation 2, we have v power 3 by 2 is equal to minus t plus 5 whole power minus 2 into 3 by 2. So we get v power 3 by 2 is equal to minus t plus 5 whole power minus 3. Equation 4. If we substitute equation 4 in equation 3, we get a is equal to plus 2 into t plus 5 whole power minus 3, which is equation 3. So t plus 5 whole power minus 3 is v power 3 by 2. So therefore a is equal to minus t 2 v into v whole power 3 by 2. So therefore acceleration is proportional to velocity whole power 3 by 2. Here this is to disprove the other options. So the correct option is option A. 18. A man of 50 kg mass is standing in a gravity-free space at a height of 10 meter above the floor. He throws a stone of 0.5 kg mass downwards with a speed of 2 meter per second. When the stone reaches the floor, the distance of the man above the floor will be. The force on man and stone system is 0 because the system is in gravity-free free space. Let the man go x meter above the floor when the stone reaches the floor. So therefore, the mass of man into x, distance travelled by the man, is equal to mass of stone into 10, which is the distance travelled by the stone. So therefore, we know the mass of the man and mass of the stone. So if we substitute, we get the x is equal to 0.1 meter, the distance travelled by the man. Option B. 19. A boy is standing at the top of a tower of 20 meter height and drops a stone. Assuming g is equal to 10 meter per second square, the velocity with which it hits the ground is. Initial velocity is 0, g is given, h the displacement is 20 meter. Let v be the velocity. We have v square is equal to u square plus 2gh. V is equal to 20 meter per second. 19 option B. 20. A particle covers half of its total distance with speed v1 and the rest half distance with speed v2. Its average speed during the complete journey is. Let s be the total distance covered by the particle and t1 be the time taken to cover the first half of the distance. Then t1 is equal to distance, which is s by 2 divided by v1, which is given by s by 2 v1. Similarly, t2 be the time taken to cover second half of the distance. Then t2 is equal to s by 2 v2. Average speed is equal to total distance by total time. S divided by total distance is s divided by t1 plus t2 total time. So we have t1 and t2. Substitute here. We get s by s divided by 2v1 plus s divided by 2v2. If we solve this, we get v average is equal to 2v1 v2 by v1 plus v2. So therefore 20 2v1 v2 by v1 plus v2, option C. 21. The motion of a particle along a straight line is described by the equation x is equal to 8 plus 12t minus t cube, where x is in meter and t is in second. The retardation of the particle when its velocity becomes 0 is. We have the equation x is equal to 8 plus 12t minus t cube. Velocity is given by dx by dt. If we differentiate 8, we get 0, and differentiation of 12t is 12. Differentiation of t cube is 3t square. We get 12 minus 3t square. When velocity is 0, 12 minus 3t square is equal to 0 and t is equal to 2 seconds. Acceleration is equal to dv by dt. So we get differentiation of this equation and we get minus 6t. So therefore substitute t is equal to 2 seconds, we get minus 12 meter per second square. So therefore the retardation is 12 meter per second square, option D. 22. A stone falls freely under gravity. It covers distances h1, h2 and h3 in the first 5 seconds, the next 5 seconds and the next 5 seconds respectively. The relation between h1, h2 and h3 is. So the question is represented in the diagram here. h1 is the distance traveled in first 5 seconds, h2 is the distance traveled in next 5 seconds, h3 is the distance traveled in next 5 seconds. So total distance is h1 plus h2 h3. Total time is 15 seconds. So distance covered by stone in first 5 seconds is given by 25 by 2 into g. The distance covered by stone in next 5 seconds, which means t is equal to 10 seconds, is h1 plus h2 is equal to half g into 10 square is equal to 50g. Distance traveled by the stone in next 5 seconds, total t is equal to 15 seconds. h1 plus h2 plus h3 is equal to half g into 15 square, which is equal to 225 by 2g. Question 3. If we subtract equation 1 from equation 2, which means h1 plus h2 minus h1 is equal to 50g minus 25 by 2g, which gives 75 by 2g is equal to 3h1. So 3 into h1, 3 into 25 by 2g is equal to 75 by 2g. So therefore it is equal to 3h1. Equation 4. If we subtract equation 2 from equation 3, we have h1 plus h2 plus h3 minus h1 plus h2 is equal to 225 by 2g minus 50g, which gives 125 by 2g. h3 is equal to 125 by 2g, which is equal to 5h1. So from 1, 4 and 3, 5. Equation 1, 25 by 2g, h1. Equation 4, h2 is equal to 3h1. And equation 5, h3 is equal to 5h1. We get h1 is equal to h2 by 3 is equal to h3 by 5. So 22 is option D. 23. The displacement x of a particle of mass m moving in one dimension under the action of force is related to t by the equation t is equal to root x plus 3. The displacement of the particle when its velocity is 0 will be. So we have the equation t is equal to root x plus 3. We get t x is equal to t minus 3 whole square. Velocity v is equal to dx by dt. So t minus 3 whole square. If we differentiate, we get 2 into t minus 3. Velocity of the particle becomes 0 when 2t minus 6 is equal to 0. So therefore we get 6 is equal to 3 seconds. At time t is equal to 6 seconds, x is equal to, from this equation, 3 minus 3 whole square is equal to 0. So therefore 23, option B. 24. A particle of unit mass undergoes one-dimensional motion such that its velocity varies according to Vx is equal to beta x power minus 2n, where beta and n are constants and x is the position of the particle. The acceleration of the particle as a function of x is given by, the velocity is given as Vx is equal to beta x power minus 2n. Acceleration is dv by dx is equal to, differentiation of this we get beta into minus 2n x power minus 2n minus 1. So acceleration of unit mass is a is equal to dv by dt, but we need acceleration with respect to x. Therefore we multiply and divide by dx, we get dv by dx into dx by dt. dv by dx into dx by dt, as we know, is velocity, and dv by dx is already calculated and velocity is already given. So if we multiply both these values, we get minus 2n beta square x power minus 4n minus 1. So 24 is option D. 25. If the velocity of a particle is v is equal to at plus bt square, where a and b are constants, then the distance travelled by it between 1 second and 2 seconds is. So velocity of given particle is v is equal to at plus bt square. Distance travelled is equal to integration of velocity with respect to time, and velocity is ds by dt with respect to time is equal to integration of at plus bt square with respect to time, since velocity is ds by dt. So ds, integration of ds is equal to integration of at plus integration of bt square. We split it. Therefore s is integration of ds is s is equal to constant is taken out, integration of t with respect to dt plus b constant taken out, integration of t square with respect to t. S is equal to at square divided by 2 plus bt cube divided by 3 plus c, because integration of x power n is equal to x power n plus 1 divided by n plus 1 plus c. Distance at t is equal to 1 second is given by s is equal to a by 2 plus b by 3 plus c. Distance at t is equal to 2 seconds is given by 2a plus 8b by 3 plus c. And required distance is distance of 2 time in time 2 minus distance in time 1 second. So therefore if we substitute the values st2 t is equal to 2 minus st is equal to 1 and solve, we get distance is equal to 3a by 2 plus 7b by 3. So 25, distance travelled between 1 second and 2 seconds is option A. 26. Two cars P and Q start from a point at the same time in a straight line, and their positions are represented by xp is equal to at plus bt square and xq is equal to ft minus t square. At what time do the cars have the same velocity? 26. Position of car P at any time t is xp is equal to at plus bt square. Differentiation of the position when displacement is equal to velocity of the car. If we differentiate this, we get a plus 2bt. Similarly for car Q, if we differentiate the displacement equation, we get f minus 2t. When velocity of cars are same, vp at time t is equal to vq at time t. Substitute the values and solve, we get t is equal to f minus a divided by 2 into b plus 1. 26, option D. 27. Preeti reached the metro station and found that the escalator was not working. She walked up the stationary escalator in time t1. On other days, if she remains stationary on the moving escalator, then the escalator takes her up in time t2. The time taken by her to walk up on the moving escalator will be. Let v1 be the velocity of Preeti on stationary escalator and d be the distance travelled by her. We know v1 is equal to d by t1. Here t1 is the given time. Let v2 be the velocity of the escalator. When Preeti is stationary on the escalator, that velocity is given by d by t2, where t2 is the given time. Distance is same in both the cases. Net velocity of Preeti on moving escalator with respect to ground. V is equal to v1 plus v2. In this case, Preeti also is moving and the escalator also is moving. So the total speed is v1 plus v2. v1 is d by t1 plus d by t2 v2. So if we solve this, we get d into t1 plus t2 divided by t1 t2. Time taken by her to walk up the moving escalator, t is equal to total distance travelled by total speed, which is equal to d into t1 plus t2 divided by t1 t2, which we calculated here. If we solve this, we get t1 t2 divided by t1 plus t2. So 27 is option B. 28. A ball is thrown vertically downward with a velocity of 20 meters per second from the top of a tower. it hits the ground after some time with a velocity of 80 meter per second. The height of the tower is, where g is 10 meter per second square. So here we know initial velocity 20 meter per second, final velocity 80 meter per second, and h is the height of the tower. We have the equation v square minus v square is equal to 2gh, from where we can calculate h. If we substitute these values, we get h is equal to 300 meter. 28 is option B. That's it. Thank you. Like, subscribe and share the video.